Hello class, today we're going to learn about rectangles. And so the first thing I want you to do is get out your flowchart also if you don't have that out. So if you find rectangle on your flowchart, you'll see that there's really only two properties that we need to cover for a rectangle, which is why it's one of the easier shapes. But what you have to remember is that a rectangle is also a parallelogram. So if I really said to you, how many properties does a rectangle have? It has 2 from quadrilaterals, 5 from parallelograms, and now it has 2 of its own unique ones. And these unique ones are the only 2 properties that make it different than a parallelogram. So the first property is probably something you remember from kindergarten or maybe 5th grade when you actually started talking about shapes and angles. If you can remember, what are the corners of a rectangle? Hopefully you remember that it has 4 right angles. Okay, so that is our first property, and that means each corner in the interior here adds up to 90 degrees. So here's 90, here's 90, 90, and 90. Okay? So a rectangle has 4 right angles. Now, keep in mind, because it's a parallelogram, opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals still bisect each other. But what the second property of a rectangle is not only will all these bisect each other, the actual entire diagonals are congruent. So when I have a parallelogram, we use tick marks. We put a tick mark here and a tick mark here, and then we put different tick marks. Well, if from here to here is 20, then here to here is 20. And so if this is 10 and this is 10, this is also 10 and this is also 10. So the thing that's nice about a rectangle is that all these pieces are the same, the diagonals are the same, and the corners are right angles. What we will come to discover later that's going to be pretty important is, because of these tick marks, what type of triangle do I have right here? Hopefully you see it. I have an isosceles triangle, and guess what I have right here? Isosceles, here isosceles, and here isosceles. Now, please do not go trying to assume that these corners are 45. That's not true. It's just that these are isosceles, and if they're isosceles, this corner will be the same as this corner. And because of alternate interior angles, this corner will be the same as this corner. So we're not going to have too many different angle measurements, but we are going to have isosceles triangles. So let's fill in our note sheet as we go along. So I want those 4 right angles and diagonals are congruent on your flow chart, and I also like it on your note sheet. Second thing just says this: every rectangle is a parallelogram, therefore has all the properties of a parallelogram. So that's just something I don't want you to forget. The only thing that makes this more unique than a parallelogram is that the corners have to be 90, and that the diagonals will be congruent in this one where they don't have to be in this one. Let's look at this question. It's not on your note sheet, but I just want you to think about it for a second. Go ahead. Absolutely, it's true. All rectangles are parallelograms, so that is absolutely true. Now be careful if I word it like this. Do all parallelograms have to be rectangles? And that's a false statement. And if you think about the hierarchy even of the dogs, if I say rectangles are below parallelograms. So for example, Labradors are under dogs. So if you think about it this way, are all Labradors, dogs? Absolutely. Parallelograms is above rectangles. So if I ask you something about the dogs, are all dogs Labradors? No, that's a false statement. So if you have to go back, think about the hierarchy of dogs. Go ahead and read this. Take a couple seconds. So you just have to be careful on how I word it. I say which ones are true for all rectangles. Well, since rectangles are parallelograms and quadrilaterals, anything that is true for both of them is true for a rectangle. So opposite sides are parallel, yes. Diagonals bisect each other, yes. Diagonals are congruent, yes. Angles are opposite angles. So E, all of the above. If I ask the question differently, like which one is unique to a rectangle, then maybe you pick out C, and that would be your answer. So just pay attention. Also, this is not on your note sheet because it's simple. If I say BD is 7, what's the length of AC? And your answer should be 7 because diagonals in a rectangle are congruent. Technically, really, this doesn't say that it's a rectangle, so it's not a very good drawing, and I don't give you anything about 90 degrees. So it's kind of a bad question, which I wish I had taken it out. But if I say it's a rectangle, then AC is 7, correct? So now I'm going to ask this question. If it is a rectangle and AE is 3, find EC, and then our answer is also 3, and that would be 3 whether it was a parallelogram or a rectangle. Here's a little bit, just going to make it bigger. I know it's not on your note sheet yet. The next problems will be. So when we look at this, EAD, I want to find EAD, which is right here. So if I put an X right here, I want to find this angle. What we have to remember is that the directions will tell you it's a rectangle. And so if it's a rectangle, we know that the entire corner should be how much? 90. And if the entire corner is 90 and you have 50 here, how much is here? So X has to be 40 degrees, correct. So they are simple rectangle problems. Let's look at the more complex rectangle problems, the ones I want you to be able to know how to do tomorrow. So I tell you that the diagonals of a rectangle intersect at O, and I give you that XYW is 56, and I give you that WY is 33. WY is the entire diagonal, so WY is 33, so is ZX, and I know that each piece will be 33 divided by 2 because they are still bisected because of a parallelogram. So let's look what the sides ask for first. XO right here is part of the diagonal. So if the entire diagonal is 33, I just need to divide it by 2, and my answer is 16.5. WZ is a side length. I'm going to wait 1 second to figure that out. Let's go to the angles first. Here's the thing about rectangles is that if you recall, all of these become isosceles triangles. And so if these are isosceles triangles, what is so nice is there's only a couple angle measurements. There's 2 ways to do this. First of all, maybe you realize this first. This corner has to be how much? 90. So if this is 90, 56, 90 minus 56 is 34. So this angle here is 34 degrees. Now, because of alternate interior angles, this up here is also 34. And this is 56 because of alternate interior, because my outside lines are still parallel. And now, if we use those isosceles triangles, If this is 34 here, guess what this is? 34. And this isosceles triangle, if this is 56, this is 56. Alternate interior tells me this is 56, or isosceles triangle, doesn't matter, is 56, and that is 34. Now, I asked you for XWO, which of XWO is 34 degrees. I asked you for ZOY. Now, you got to be a little careful. ZOY is right here. We haven't found that yet, but we have two angles in a triangle with one missing. So how am I going to find that? So I'm going to take 180. I'm going to subtract 34 and 34, and I am going to get that it's 112. So I'm going to put up here 180 minus 34 minus 34. Okay. The last thing we have to do is be able to find a side length given this rectangle, and this is not an easy problem. So if I just draw a triangle, I know that this is W, Z, Y. I'm just drawing this triangle, and there's a reason I'm drawing it, because at Z, what is the technically what angle is at Z? A right triangle. And if I can get a right triangle, I know that I can either use trig ratios or Pythagorean theorem. So if I'm trying to find WZ, which is right here, I'm going to put an X. Let me make that a little better. Alright, I'm going to put X out here. Now, I know that's what I want to find. I have WY because WY in the rectangle is the diagonal, and the diagonal from my directions is 33. So I only have two sides, so I don't have enough to use Pythagorean theorem because I don't have this side. But I know that this little angle here, which is ZYW is 34 degrees. I can use that one. Or I could use this one up here, which is 56. It's your choice. It doesn't matter. But I'm just going to do this. Now, take a second. Am I going to use sine, cosine, or tangent to figure this out? Take a second. If you're thinking about it, it's opposite and the hypotenuse, so I'm going to say the sine of 34 over 1 is equal to x over 33. I'm going to cross multiply. X is sine 34 times 33, so that's 18.5. So I know this is not an easy problem at all. Thing is, you got to get comfortable with rectangles. What I want you to do is go ahead and try this one on your own, this problem. I give you that this angle is 62, and I tell you QS is 18. So I'd like you to go ahead and try it all by yourself first. Pause the video, do it all, and then I'll explain. All right, I am hoping that you paused the video and did try it by yourself. So first thing I'm going to do is I'm going to say I know that the entire diagonals, both of them are 18, because that's what my direction. Okay, so I have to do this kind of quick, but PT is going to be half of the diagonal. So if the whole diagonal is 18, it's going to be 18 divided by 2 is 9. If this is 62, the one thing I'm going to remember about rectangles is that the corner is 90. So if this is 62, I can find x by taking 90 minus 62. So this is 28 because that's where I put x. Then, because of either isosceles triangles or even alternate interior, I know that if this is 28, this is 28. Isosceles triangles tell me this is 28, this is 28. So to find PTQ, I take 180 minus 28 minus 28, which is 124. And then lastly, the last thing I'm going to do, I'm going to look for SR. So I'm going to make a right triangle right here, and I'm going to redraw it down here, and I'm going to use trig ratio. So I'm going to put this here. This is 90. S, R, P. I know PR, which is QS, is 18. I know this is what I'm looking for. I need one angle measurement. You could choose 62 or 28. I'm going to put 28 here. Go ahead and use your trig ratios. Now, I know I had to do this fast, but I would set it up like this. I'd use cosine 28